Lunchtime.
Sunshine. I said sunshine.
Oh, sunshine. Heck yeah, man. I am loving the sunshine. I think that's why it's making it like even more difficult these last couple days because I sit out and I just like look at the sun and I'm like, "Ugh, ugh." It's like being trapped inside. I can't. All right, guys. So first off, thanks for being awesome, flexible, and all the things yesterday. My daughter's school called and they're like, we got a situation. So I had to like last minute like jet out of that, like jet over there. I was like, oh my gosh, are you kidding me right now? Like her sugar levels were going all berserko. I'm like, story of my life right now. I was like, that's why I feel like I'm army crawling to like the finish line. I'm like, oh my God. Ugh. So I appreciate you guys. Hopefully you were able to use the time to finish up your notes or to watch the video where I went over the notes. Oh, my screen's a weird thing, but going over those notes, it is posted still for you guys, so feel free to jump in and do that. We do have our mid-unit quiz tomorrow, so it'll be a shorty little day. We will do a review, fun stuff before the quiz, and then I will get that to you. But basically, after today's activity, we have one left. One and the review, and then we're done. Done. And then the test. I mean, wah, wah. But you guys are all killing it anyway. So, you know, this is a face of pure worry that you won't kill it. So, you know. But for this elaborate activity, we're going to look at trophic cascades. We've actually saw trophic cascades a couple of times kind of embedded throughout with some of our activities. So when you guys did the first activity where you guys were doing the engage, you watched that video and it was looking at the sea stars. That was actually an example of a trophic cascade. When you were doing your notes and you were examining what was happening with the food web, especially with the removal of the sharks, that was an example of a trophic cascade. So we're going to dive in a little bit deeper and kind of I'm going to walk you through kind of how to analyze trophic cascades. You will see it on a test and in our final activity of the unit. There are some slight, how would I say this? There can be some confusions about some of the symbols that the interactive uses, so that's why I want to make sure that we go over it to make sure there's everything is squared away. So we're going to go through the first parts together. Then once everybody feels like they're solid, they're good to go, you guys can then go ahead and finish it on your own. But our big learning targets today would be to determine the effects that each organism in a food chain has on the others. Remember, it's all about this interconnectedness within our ecosystems and how it plays a role. And while some organisms' roles are more important, they still play a role and can have serious effects on an ecosystem, both direct and we're going to start looking at this new one, indirect effects on the health and stability of an ecosystem. Okay. So first things first, we are going to be working together in our notebooks on slide. Let me get back to the right slide. Slide 10 is where we're going to start. And I probably should have made sure I wasn't blinking. Yeah, okay, we're good. So as I go through here, make sure you guys ask any questions you might have. You can use the raise your hand function or just drop them in the chat. Hi, Gabe. Hi, Shaprit. So with this, you guys are going to be using an interactive, and that interactive is posted in Google Classroom. I'm going to be sharing my screen so you guys can decide kind of how you want to do this for the first part. If you just want to follow along on my screen and then you don't have to have it open at the same time and then trying to be doing the same thing in two different screens. And then you can open it on your own later, or you can open it now with me, either way. Okay. So if I go over to Google Classroom, I'm going to go to lesson 4, the elaborate. Again, I should have added this right now for you guys. It wasn't due last Friday. It's actually due like tomorrow. Also, it's not really, it is an assignment, but there's nothing you would have to attach. It's just so I could individually share some stuff with you guys. But you're going to select the link, okay, for the interactive, and it's going to pop you to the screen. And then you're going to hit launch the interactive. Okay. Pop. And it's going to bring you to a whole new separate screen. And I might have to try to resize it because it's kind of goes a little bit haywire here. Okay. I'm going to try to see if I can. I don't know why it's being all funkadelic here. Have I ever told you guys how much I love technology? How it's so awesome sometimes. All right, let's see if that works. Okie dokie. There we go. Okay. So as we move through, there are 3 different parts to this interactive. You have the introduction. We're going to go through it's called a kelp example, and then you're going to have 4 case studies. I'm going to do the first of the case studies with you, along with the kelp example and the introduction, and then you guys will have the last 3 case studies to do. And we're going to be kind of doing that side by side with our notebook. Okay. So you guys can follow along as we go through this. So ecosystems are comprised of a community of organisms and their physical environment. Ecologists study the interactions among these organisms and the factors that affect organisms' distribution. The structure of an ecosystem can be represented by a pyramid made up of what we call trophic levels, such that the producers are at the bottom, followed by primary consumers, secondary consumers, and so on. This click and learn illustrates examples of what can happen when the top of a pyramid changes. How are the levels below affected? How does the ecosystem change? So a simple trophic pyramid this is a simple trophic pyramid from the coastal Pacific Ocean showing the kelp forest that is eaten by sea urchins, which are eaten by the sea otters. Okay, so remember, ecosystems are basically a collection of different species that exist in a set area. Okay, when we use the term ecosystem, we're really that prefix eco means house. Okay, the system piece is what's going on in the house. What does the house look like? Now, the size of your ecosystem, you always have to predetermine. So if I asked you about the ecosystem in your particular house, it would look different in size and makeup than my house and Faisal's house, than Miss Cannon's house, than Morgan's apparently bloody house right now. Okay, so everybody's ecosystem and every ecosystem that's on a planet is different, both in size and makeup. Okay, we can even take this into consideration and apply it to the ecosystem within Auburn Riverside. Okay, we have different numbers of different groups. Okay, so think let's say one species was the freshmen and another one was the sophomores and another the juniors and the seniors, and you have the staff and you have the custodial staff. So even within the staff, you have teachers, administrators, counselors, all of those things working together and impacting each other. And the stability of an ecosystem really is about the interactions. Okay, so just kind of remembering that. Now, what they're saying here is that we're going to look at what's called a top-down approach. So what are our top-down? That was one of your beginning terms. So what's top-down versus bottom-up? So when we start making changes to food chains, okay, and in this case, we're going to represent our chain as a pyramid. When you make a change to the top, what are the effects that it has moving down? That's our top-down. Versus what if I change the bottom, how would it affect the things above it? That would be a bottom up, okay? Now, this guy, okay, fun fact, otters are my favorite marine animal ever. I think they're the cutest things ever, and I wanted one for the longest time. I actually wanted 2 because they're buddies and they play together and they roll around and they snuggle. Oh, they melt my heart, but they're also kind of mean, which also I kind of like too. So they're my faves. But we're going to watch a quick video that's going to actually talk about this relationship. And it's a little bit of a recap of what we went through at the beginning of in our first activity, at the beginning of the unit. Okay. So follow along on this guy. And I'm going to probably mute my screen because it seems to save on the echo to enjoy.
The experiment was simple. Compare ecosystems with otters to those without. He began with his home island of Anchitka.
I knew a lot about what Amchitka looked like. I knew that sea urchins were common but very small.
The next step was to arrange for a dive at nearby Shemya Island, a location with no otters.
The most dramatic moment of learning in my life happened in less than a second. And that was sticking my head in the water at Shemya Island. It was just green with urchins and no kelp. And it all sort of fell into place in just an instant. That the loss of otters from that system had completely reorganized that system, from which kelps had probably been very abundant before the loss of otters, to one in which the sea urchins now had become abundant in the absence of the otters and had eaten all the kelps.
Sea otters, the predators, were controlling the urchins that fed on the kelp. Remove the sea otters, and the kelp forests disappear. Payne called these cascading effects of one species downward upon others trophic cascades.
Trophic cascade is when you have an apex predator controlling the distribution of resources, and they lead to these cascades of indirect effects. Lots and lots of indirect effects. You have fewer sea otters, you have more sea urchins, you have fewer kelp.
I expect every coastal species is probably impacted in one way or another by the presence or absence of kelp. Kelp forest fishes depend a lot on kelp. There are birds that feed in the kelp forest. There are invertebrates that feed in the kelp forest. Virtually everything that lives in the coastal zone depends upon that system in some way.
All right, so let's take a deeper look about some of the things that he brings up here. Okay, now when he's, like I mentioned, so he talks about, okay, one, what were trophic cascades, and two, this whole idea of either having a direct effect or an indirect effect. Okay, and there's two different, and there's some pretty big differences between the two. Now, in a direct effect situation, you are going to see it's going to be like, let's say the predator, it somehow changes, and it will have a direct impact on the thing right next to it. Okay, so the one way you can figure this out if you're going to be looking at a direct effect is in the food chain. Okay, are they right next to each other? Now, that's not to say that if I change something up here, you can't analyze the relationship in that change to something else. So like over here, what they were showing you, let me replay that over here. So notice that, yes, you're going to have these guys in that sequence. However, we can ask, okay, what is the effect of changing the otter population on the kelp population? When you are skipping levels like that, that is representing, you're asking really, what is the indirect effect? Because the sea otters do not directly engage with the kelp. They don't eat the kelp. That's not their food source. They eat the things that eat the kelp. So if you're skipping over levels, you're looking at indirect effects. If you're going level by level and you're looking link by link, that's direct effects. Okay, does that kind of make sense for everybody? And let me know in the chat if that doesn't. All right. Now, so let's go back to our notebook and we're going to complete that first question and then we're going to move into our kelp example. Okay, so let's go into here and let's create an example or a definition for what a trophic cascade is. Okay, so let's see, based off of the video and what we've seen so far, a trophic cascade is really the ability of a predator to control the distribution of populations found in the lower trophic levels, often in an indirect Man. Now, I want to be sure to kind of add this because when we're looking at trophic cascades, that's one of the biggest things that especially James Estes found was the presence of these indirect impacts. This is what he was most like mind blown about because we don't necessarily notice the indirect effects of the actions that that take place. We always notice the direct effects. Okay, so what he's saying is like, whoa, we never realized the ecosystems were so impacted by all of these afterthoughts. Okay, it's like think of like a rippling effect. You drop a boulder in the water and it's gonna make a big splash, but you have all these little waves that come off of it. Okay, and it's those little waves that can add up and create a massive shift in how that particular community, okay, of different species is going to behave. So what really a trophic cascade is looking at is you're going to change the top and we're going to see this rippling effect all the way down. So how does taking the top predator, changing it in some way, affect the distribution or amount of each population that lies below it? Okay. All right. So we're going to use that example that he brought up in the video of the kelp. Okay, so how is the kelp population changing, especially with regards to the otter? Now, there are 4 different symbols that you're going to use in this interactive. You're going to have solid arrows, dashed arrows, minus signs, and plus signs. And they're going to mean going to have 2 really important meanings here. Okay. So let's flip back over into our kelp example, okay, to start looking at what these guys mean. Now, if you're looking at this kind of linear relationship here, so you had your otter was directly linked to your sea urchins, which is directly linked to the kelp. Okay, so if they go in order like that, that's where we're showing those linkings, means they're directly related. Now, to show that direct relationship, you're going to use solid lines. Okay, so solid lines in between each of those different species. So there is a direct relationship between the otter to the sea urchin, so we're going to use a solid line. Now, here's where it gets a little tricky, and where we're going to take it all the way back to first semester, and I mean like all the way back to our first unit, when we started looking at homeostasis and feedbacks. Now, remember, if you think all the way back there, we had negative feedback and positive feedbacks. When you had a negative feedback, okay, so remember like negative feedback loops, when we did that, you're like all probably thinking like, what, I like block that whole thing out. Okay, it's gonna come back to haunt you a little bit. Remember, when you have a negative feedback loop, an example would be like your temperature, how do we regulate our temperature? So if your temperature goes up, okay, your body has to do something to force it to come back down. So the response is opposite. That's where that use of that term negative comes from. So in that regard, you're looking at opposite response, action response sequences. When you have positive feedback, it was where both the response and the action are both going in the same direction, whether they're going to go up, up, or down, down. It's still a positive connection, a positive correlation. So if they're negative, we just use, they're going to go opposite. If they're positive, whether they go both up or both down, they're just going in the same direction. That's where we use a positive. Now, in this example, let's say we're going to see the sea otter population decrease, right? So this guy's population goes down. If that was the case, how would that affect the sea urchin population? Okay, so in the chat, how do you think that would affect the sea urchins? If we started to decrease, okay, your otters, what would happen to all the sea urchins? Would that population increase or decrease? Yeah, you've taken away its predator. Now these guys are living their best life. They're like, no one's here to eat me. Awesome. Okay, but notice the difference. Sea otter population down. Okay, the sea urchin population up. In this case, that's where you would use a negative sign to show that those two populations respond in a negative correlation. Okay, one up, one down. So they're moving in opposite directions from each other. Yes, Christy. Okay. Now let's look at here. So if I just said, okay, now if the sea urchin population has gone up, what do you think that means for the kelp forest? Do you think the kelp forest population is going to go up or down? If I've got more of these in the area now. Yeah, they're also going to decrease, okay? So they're gonna go down. So again, if they're doing the opposite, I'm gonna use this negative sign to show that they're doing something opposite of each other. And notice how I have that solid line because there's a direct relationship between the sea urchins and the kelp. Now here's the difference, okay? Oops. Now if you notice, okay, I said this guy's population was going down and this population was going down. Now, when you are having an indirect relationship, so how did the removal of the sea otters impact the kelp? There's a whole lot of steps in between, okay, between the kelp and the otter. That's when we would use that dotted line to show an indirect relationship, okay? Because they don't directly engage with the kelp, but through a couple of different middlemen, they would. Now, because they both, the kelp or the sea otters go down, kelp goes down. Notice how they're facing the same way. Both go down together. They're positively correlated together. Okay, so because they go down, other goes down, we're going to use a plus sign.
I don't think that we can see that because you're showing your notebook right now.
Oh my gosh. Thank you, Colin. Christy, is that probably what you were asking about? You're like, I don't even know which one we're on right now.
Yeah.
You guys are so studious and polite. That's where you guys have to be like, hey, lady, I can't see your screen. Okay, so all that jibber jabber that I just said, here's what I was looking at. Okay, so you've got your sea otters. Their population is going to go down, which is going to cause your sea urchin population to go up. And that's where you're going to use that negative sign because they're doing the opposite. Your sea urchins are directly related to your kelp, so we're going to use a solid line or solid arrow, okay? But they're still doing opposite of each other because when you have more of the predator, you're going to have less of the prey. But when I look to see and I skip over the middlemen, and I notice that the otter population went down, the kelp population went down, that actually means they're positively connected. What one does, the other will do. So if I were to increase the otters, you're going to see an increase in the kelp. Okay, so they will work together. Okay, so now let's go back to your notebook. Let me get back on board and not be such a weirdo. Okay, now we can fill out that middle section. So those solid arrows are going to represent a direct effect on a population. Okay, so that's where you're gonna see, okay, there's a direct effect here. When you look at those minus signs, okay, you're looking at an example of negative feedback where there is an opposite effect that happens between two populations. Remember, one goes up, the other goes down, or one goes down, the other goes up. So they work opposite of each other. Now, when you have your dotted line or your dashed arrow, okay, that's going to represent the fact that there is an indirect effect on a population. And those plus signs or those positive signs are going to show a positive feedback where they're going to have the same effect. Okay, so the two spots between the arrows, the start of the arrow and the end of the arrow, they're both doing the same thing, whether that's going up and up or down and down, it doesn't matter. Okay, it just means that the effect is the same. All right, in the chat, how does that, yes, you got it, no, you're like, I'm lost and that makes no sense. Good. Now remember, the way an ecosystem works, okay, so what we looked at is one food chain. But really, ecosystems are not made up of one food chain. If it were, that would be the weakest ecosystem ever. Because really, ecosystems, they are made up of a lot of food chains or a giant food web. And the more hot mess that food web looks, the more interactions and overlapping, okay, there are, the stronger that food web is. So when we remove or we mess with one organism in one food chain, you will see the rippling effects throughout the entire ecosystem. So specifically, let's take a look at how the removal of that otter is going to affect two other species in that ecosystem, and the ones that you wouldn't even think. Okay, so first off, the seagull, and the second would be a bald eagle. Okay. So I'm going to flip over to the interactive and I will come back to this page. So if you guys are, if you're jotting this stuff down, don't worry, I'll be back to this slide. Okay. So we go over to here. Okay. Now this guy, okay, these, if you've ever been to any waterfront in Washington State, you've probably seen these awesome little friends. If you've ever eaten food there, they probably try to steal your food because they're little scavengers and they're punks and they're fearless and they don't care. So these are your typical seagulls that you guys are going to see around the Pacific Northwest. Okay, they are omnivores, but their primary food sources are going to be mainly fish and marine invertebrates. Okay, and sometimes they'll also eat the eggs or chicks of other birds. Okay, if that's what's around. Okay. Now, doesn't seem like really the otters would play much of a role in the survival of these guys, but it turns out what they found was that when they took away the otters, the seagull's diet massively shifted. Okay, so they predominantly, like around 90% of their diet was made up of fish. Okay, when the otters were there, when they removed the otters, their diet dropped to what? 10% fish, 90% invertebrates. Okay, now invertebrates are any organism that lacks a vertebrae. Like you are a vertebrate because you have a spine. Okay, so it's any like spineless organism or that lacks like any sort of structure. So think like a mollusk or something like that that's typically more squishy. Okay, that's what their diet consists of now. Okay, so we see this massive shift in what these guys are eating. Okay, now the next guy, okay, that we're going to take a look at, and we'll go back and we'll finish up those last two questions together, is the bald eagle. Now, once endangered because of human activity, bald eagle populations have recovered to the point that they no longer are classified as endangered or threatened. Whoop, whoop. Bald eagles specialize in eating fish, but they are opportunistic raptors and will include small mammals as well as other birds in their diet. So, side note, these guys are savages. They live around, we have a lot of bald eagles around our house, and fun side note, we get messages all the time on our like community page because there's a lot of people around here who have those itty bitty tiny dogs, like little teacup dogs, and they'll be out in the yard, and we've had quite a few residents out where we live tell us that the bald eagles will swoop down and snatch them up out of the yard and carry them away. Like, bye-bye, little pup. It's nice knowing ya. Like, these guys are no joke. And they literally just, like, their beak is so strong, like, and off they go. Savages. Okay? So what happens when we remove the otter? How does this disrupt their diet? Okay. So again, what they found was that prior to the removal of the otter, their diet was, relatively balanced. So they ate other birds, okay, or they ate fish, and then if needed, they kind of threw in some other small mammals. But after they took out the otters, they ate a lot of other birds, okay, very few fish, and even fewer mammals. So we see this mass disproportionate distribution on their diet, okay? All because of the otter. So let's go back to our notebook, okay? And let's do a quick little fill-in for question 3. So how does the removal of the otter affect the goals? So their diet shifts from mostly fish to mostly invertebrates. For the bald eagle, their diet shifts to mostly birds. Okay. So for the case studies, we're going to be using these symbols, and I'm going to walk you through here. I'll leave it here so you guys can kind of copy this down. Okay, but we're going to be using these symbols to describe what is happening in 4 different trophic cascades. Okay, the first one we're going to look at is going to be one about the Arctic tundra. The other is going to be the one that's happening in the Midwestern lakes, then the African savanna, and the Venezuelan jungle. So we're going to see about 4 different scenarios here. Okay. All right. Now, what you guys have for each of your scenarios, or we're going to start on slide number 11. Okay. And you're gonna notice that you have the diagram is gonna look similar to what we saw in the interactive. So we're gonna have the organisms listed below, and we're gonna drag and drop them into their correct spots. I've already have the arrows in here for you. So remember, the solid arrows represent direct relationships. The dashed arrows are going to represent that indirect relationship. What you need to do is we're going to figure out after we go through them, okay, are we seeing a positive feedback where they're going to do the same thing, those 2 populations work together, or are we seeing a negative feedback where they're doing the opposite of each other? These arrows right up here are going to be used, and you're going to drag an arrow over each of the boxes to show what that population is doing. So is it increasing or decreasing? Now, I know there's only 2 of them, so you're going to have to cut and paste. So 2 different ways you can do that, or actually 3. So you can highlight it, so by clicking on it. If you have a mouse, you can right click, hit copy, okay, and then right click and hit paste. Or you can highlight it. You can hold down the control and do control C, click off of it, and do control V, and another one will pop up. So you're going to need to make multiple copies of these as you work through, okay? All right, so let's flip over and let's look at the scenario, and then we'll come back over here and we're going to build out our little model here. All right, so the Arctic tundra. So in addition to controlling the relative amounts of primary productivity, trophic cascades can also change the landscape by altering the movement of nutrients through the community. In this example, the introduction of Arctic foxes had effects beyond the birds that they ate. So the first question is, do foxes have a positive or negative effect on the seabirds? Okay. So what do you guys think? Do they have a positive or negative effect on the seabird? So if I'm going to increase the fox population, and the seabirds are their food source, okay, how do you think this will affect them? So you're thinking negative. Okay, so when you guys are going through, when you select them, whoop, it will tell you, yay. If you select the wrong one, it's like, try again. Okay, so yes, correct. Since foxes prey on seabirds, if their numbers increase, there would be a decrease in the seabird population. Okay, so we're going to have a negative arrow or a negative sign for that one. Now, knowing that your seabird population has gone down, okay, how do you think that affects the soil nutrients? Now, how this works right here, because there was a little bit of confusion first period. Soil nutrients, okay, remember how the way that nutrients gets back into the soil is, let's say the seabirds would either have to die, and then decomposers would break down their bodies and return those nutrients into the soil. Think very Lion King right now, like Circle of Life. Okay, or the seabird population has to like poop all over the soil and it's like natural fertilizer. Okay, so if you have less of the birds though, okay, how much of that nutrients do you think there's going to be? Okay, do you think the amount of nutrients is going to increase or decrease? You guys can let me know in the chat. So foxes went up, seabirds went down. So if they're down, how much nutrients do you think we're going to have? Okay, yeah, these guys, the amount of nutrients will also decrease. So remember, if you're both going down, okay, so should I use that plus sign or that minus sign? Okay, let's see if I do use the minus sign. Not wrong. Remember, your minus signs, they're going to only happen if your populations are doing the opposite of each other. So because our seabirds went down, they're not going to be able to poop all over the soil. So there's going to be less of that, like, poop fertilizer, like dripping into the soil and whatnot. Okay, which means that there's going to be less nutrients. So if both of your arrows are pointing in the same direction, then you can use that plus sign. Yeah. Now think about it. The nutrients are needed by the plants. Plants need this. Okay, and that's how they get their nutrients. When we fertilize like naturally into the soil, it gets all nice and rich, and the plants take up those nutrients so they can perform photosynthesis. So if we have less nutrients, how do you think that's going to impact the grass population? Do you think we'll have more grass or less grass? Yeah, so we're going to decrease the grass population. So notice like which way my fingers are pointed. If we're both pointing in the same direction, then that means that we're going to have that positive correlation there. One goes down, the other is going to go down. Okay. Everybody good to go? I know that that's kind of, it's like counterintuitive because what you're looking at right now, you're kind of using it like, okay, I have to think about what the population is doing. And then it's almost like you have to pick the opposite. So I feel you that can get a little bit confusing, but once we go back to your notebook, you'll kind of see the two different symbols and then it'll make a little bit more sense. Okay. Oops. Come on, little buddy. Beep boop. Oh. This one was going to be, I don't know. All right. So based off of the introduction of that fox, okay, what do we expect the landscape to look like in the Arctic tundra? Definitely not going to be green and thriving, right? They don't have as many nutrients. Okay. Now notice because we were comparing, we were analyzing the fox's introduction to the grass. So when you are skipping over all of these direct relationships and like kind of jump into the end, you are really analyzing an indirect relationship. So that's why we think of it like they have to hop over all these steps. That's kind of like the way you can think about the little dotted lines, like, oop, hop, 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 hop. Now, the reason why they use that negative symbol, remember, is because the fox population went up, but the grass population went down. So notice the directions. So because they were opposite of each other, we're going to use that negative sign. Okay, so let's go back to our notebook, and then I'll walk you through how to fill out that table on slide 11. Okay, so first thing you're going to do is you're going to drag all of your little populations into their correct spots. So I have the Arctic fox, and yours might be in a different order because remember I did this already once, so I just kind of drug them down. Then they're going to eat the seabirds. The seabirds are then going to add soil to or nutrients to the soil. Then those nutrients are taken up by the grasses. Okay, so I've got my organisms in the correct spaces. Now, the easiest thing to do is kind of like what we were doing and analyzing, okay, what is happening to their population? Is it increasing or decreasing? So with the introduction of the Arctic foxes, that means the Arctic fox population was going up. Okay, so I'm going to copy one of my up arrows and just kind of drag it and set it right on top of there. Now we said by increasing that fox population, that also means we're going to see a decrease in the seabirds. Now by decreasing the seabirds, there's less nutrients available in the soil, which means that there's going to be less grass in the area. So as your second step, you want to kind of decide what direction are we increasing or decreasing for each of the populations. Now it makes it a little bit easier to go back and use those negative and positive signs. So from here to here, you're going to compare, okay, are they going in the same direction or different directions? In this case, you're indifferent, so I'm going to grab my negative sign. And I'm going to drop it into that spot. Now the second one, between here and here, they're both going in the same direction, which means that I'm going to use a positive. So these have a positive connection, meaning that they will work in the same way. Same thing with your soil nutrients. One goes down, the other goes down. One goes up, the other goes up. And then here to here is where we have to connect and make that connection. So one went up, the other went down, which means you're going to drag that negative sign right up there. So you may end up with extras. So we kind of provided you with lots of options. Okay, and you're going to have to make a copy of here. And then the last thing you would do for each of your case study is describe what happens. So what indirect effect does the predator have on the soil nutrients in the ecosystem? How does this affect the landscape? So as the last piece, I might say something like, okay, let's see. So the predator or the Arctic fox has an indirect negative effect on the soil nutrients in the ecosystem. The introduction of the Arctic foxes also causes the reduction of the seabirds and the and the grasses. So you're going to just write me a quick little explanation describing the loop that you created. Okay. Okay. All right, in the chat, good to go? Not so much. Again, as you guys are able to kind of click back and forth on your own screens, it is a little bit easier to pause and go back and forth to fill these out. That would be my suggestion. So when you're working through the next case study, kind of look to see what the organisms they have in order, jump back into your notebook, then place them. Then go back to the interactive. So kind of flip back and forth, And then that will make the easiest, it'll make it a lot easier. So as you're deciding, okay, once they're in their spot, then say, okay, what's happening to the population? Is it going up or is it going down? Up or down, up or down, up or down. Okay. And then you can, as you work through, remember, it gives you the correct answer in the interactive. So if you click wrong, it's going to say, nope. And then it'll have you click the correct answer. Okay. At the end of each scenario, it also provides you an overview of what happened. So that's what you can use to kind of formulate your response to the last questions. Okay. All right. So I'm going to give you guys some time to go ahead and work through those 3. And then tomorrow at the beginning of class, we'll go back through and we'll see how you guys did if we all ended up on the same page. Okay. If you have questions or you are confused at all and you want to stick around and work through any of the other ones, you can totally do that. If you're feeling good, then you can go ahead and you can jump on out on your own and finish it up. Okay. Other than that, I'll be on till 1:45 if you guys need any help.